To find exactly nth roots of the given complex number expressed in the polar form, you have to use the nth root theorem, which gives you any nth root, one of these nth roots, as the nth root of the r, or the nth root of the modulus of the complex number, multiplied by the e raised to the power of I, the imaginary number, times the theta, the argument of the complex number, plus 2 pi k divided by n. Okay? And this equation here is valid for k starting from k values of 0 all the way to n minus 1. Why doesn't it not end on n? Because we start from 0, right? We didn't start from the 1. The first root will be found by setting the k value of 0. Thus, you will only need n minus 1 evaluations because you're starting from 0, and that will be valid for nth roots. So now we need to use that. We need to use this equation here, this theorem, to find the 4 fourth roots of 81e to the I times 2 pi over 3. So as you can see, the first thing that you should notice is that n will be equal to 4. Okay, and how do we know that? Because we can find, we know that n is going to be the fourth root in this question, right? It matches the 4 number, and it matches the fact that we need to find the fourth roots, right? 4 fourth roots. So this is the n value in itself. This is the value 4. Now, the next thing is to know that the angle theta, or the argument of the complex number, is going to be equal to 2 pi over 3. Okay? 2 pi divided by 3. So now we can express any one of these 4 fourth roots as simply this. The fourth root of 81 being multiplied to e to the I, and then we will have 2 pi over 3, because that stands for the argument theta, plus 2 pi k, and that will be divided by 4, the n value. Okay? So now, and this is true for k, 0, 1, 2, and 3. Okay? Because we will have exactly 4 fourth roots, so you will have 0, 1, 2, 3, and that will be sufficient. Notice you don't need to find k value of 4 because you're starting from the 0. There are 4 numbers. 0, 1, 2, and 3 constitute 4 numbers, each one responsible for one of the fourth roots. Okay? So now, the first such root is going to be the w subscript 0, when the k value is equal to 0. So now it's going to be 3e to the I times pi divided by 6. Okay, and how did I get that? I got that from the fact that when k is equal to 0, this thing goes to 0, right? So this whole thing goes to 0. And then essentially what happens is you will get 2 pi divided by 12, right? Because you divide this 3 by 4. 2 pi over 12 is the same thing as pi over 6, simplified. Right? So I know that. Now I'm going to convert this to the trigonometric form from the polar. And we know that the modulus 3 stays there, so it's going to be cosine of pi over 6, right? The theta stays there as well, the argument, plus I sine of pi over 6. And that leads to 3 times. Now cosine of pi over 6 is radical 3 over 2. Right? This angle is in quadrant 1. Both sine and cosine are positive in quadrant 1. So sine of pi over 6 is going to be exactly 1/2, right? So we can just divide I by 2 here. So the result here, the first fourth root, is going to be 3 radical 3 over 2, just distributing the 3, plus 3 over 2i, right? So this is the first fourth root that we found. Now the second one, we let k be equal to 1, so it's going to be 3e to the I. Now, what is the angle going to be? When k is equal to 1, we get 2 pi over 3 plus 2 pi. Basically 2 pi over 3 plus let's see, so I'm just going to write this down. 2 pi over 3 plus 2 pi, which is, with the LCD here, is going to be 6 pi over 3. And that will be divided by 4. So what we get is 3e to the I, and then 6 plus 2 is 8. 8 pi over 3, or 8 pi over 12, is the same thing as 2 pi over 3. Okay, this simplifies to 2 pi over 3. So now what we get is 3 cosine of 2 pi over 3 plus I sine of 2 pi over 3. So that gets us to 3. Now this is going to be in quadrant 2. In quadrant 2, the cosine is negative, the sine is positive. So cosine of 2 pi over 3 is negative 1/2. And then sine of 2 pi over 3 is exactly radical 3 over 2. So what we get is minus 3 over 2, distributing the 3, plus 3i radical 3 divided by 2, right? So we found the second fourth root of the given complex number presented in polar form. The third root is going to be with k value of 2. So that's going to be 3e to the I. Now here's the thing. K is going to be equal to 2, so this is going to be 4 pi, right? So 2 pi over 3 plus 4 pi. And this whole thing divided by 4, the n value. So then we get e to the I. And then let's see. This is going to be 14 pi basically over 3. 14 pi over 3 also divided by 4 is the same thing as 14 pi being divided by 12. 14 pi divided by 12 is the same thing as 7 pi divided by 6, right? If you reduce it. Okay, so then we get 3 cosine of 7 pi divided by 6 plus I sine of 7 pi being divided by 6. So this is going to be in quadrant 3. Both cosine and sine are negative. So the cosine of 7 pi over 6 is going to be minus radical 3 over 2 plus I, and the sine of 7 pi over 6 is going to be negative 1/2. So this should give us minus 3 radical 3 over 2, distributing the 3, minus 3i divided by 2. Okay, so we found the third fourth root of the given complex number. Now the last root, k value will be 3, is equal to 3ei. Then the angle here is going to be what? So we know that k is going to be equal to 3, so this whole thing is 6 pi. So 2 pi over 3 plus 6 pi, and this whole thing divided by 4, the n value. Now we get 3e to the I, and 6 times 3 is 18, so 20 pi over 3. 20 pi over 3 also being divided by 4 is the same thing as 20 pi being divided by 12, which is the same thing as 10 pi being divided by 6, or the 5 pi being divided by 3, right, if you reduce that. So this is what we get. Okay, so now as a result we get 3 cosine of 5 pi over 3 plus I sine of 5 pi over 3. So that gives us, now this angle is going to be in quadrant 4, okay, right before 6 pi over 3, right before 2 pi, it's going to be in quadrant 4. In quadrant 4, the cosine is positive, the sine is negative. Okay, so the cosine of 5 pi over 3 is positive, it's 1/2 in fact, and the sine of 5 pi over 3 is negative, it's minus radical 3 over 2. So this result is 2, just distributing the 3, minus 3i radical 3 divided by 2. So I hope this was helpful. We have found successfully all 4 fourth roots of the given complex number presented in polar form. Thank you so much for watching. See you in the next video.